Okay, so we're going to evaluate some different combinations of functions. If you see something like f plus g of 2, basically that just means that you're taking f of 2 and g of 2 and adding them together. So if I do them individually, going to function f and plugging in 2 for my value of my variable, I get 0. G of 2 is going to give me, let's see, 2 times 2 plus 6, it's going to give me 10. So f plus g of 2 is just 0 plus 10, or 10. So it's just basically a little different notation. If you see something like f g of 0 with them switched together, that's multiplication. So it's f of 0 times g of 0. Again, go up to your two functions, f and g, plug 0 into each one, and then multiply your results together. So if you plug 0 into f, you get negative 4. If you plug 0 into g, you're going to end up with 6. And then if you multiply negative 4 times positive 6, you're going to get negative 24. Composition of two functions is when you basically have one function inside of the other. So you're performing the operation of your inner function first, taking whatever result you get, and then plugging it into your outside function. So it's kind of like do one thing, take your result, do another thing to it. So if we do one here, I'm going to start with e. I'd like to rewrite it with my other notation. So we're performing f of 2 first, it's our inner function, and then taking our result and plugging it into g of x. So I'm going to f of x and plugging 2 in for my variable. That's going to give me 0. And then if I take that result that I got from doing f of 2 and now plug it into my outside function, which is g, if I plug 0 into 2x plus 6, I'll have 2 times 0 plus 6, which is just going to get me 6. So our end result, g of f of 2, is equal to 6. Let's do one where you don't have a value to plug in for your variable. I'm still going to rewrite it. So this is f of g of x. Order is important, so make sure your inner function is your second one. Well, g of x is just 2x plus 6, with x as itself, not replaced with any number. So I'm going to take that whole 2x plus 6 group and plug it into f of x. So make sure to put it in its own set of parentheses. You're going to have 2x plus 6 quantity squared minus 4. And then we're going to need to actually do that. So if we square 2x plus 6, write it out and take it times itself, and then subtract 4 from it. That's going to be what f of 2x plus 6 and f of g of x is. So I'll have 4x squared plus 12x plus 12x plus 36 minus 4. So my final result when I combine like terms is 4x squared plus 24x plus 32. So you don't just have to have equations that you use to evaluate different combinations and operations on functions. We're going to use a graph here to find f plus g of 4. So I want f of 4 plus g of 4, which basically if you're looking at a graph, f of 4 says, hey, if my x value is 4 for my input, what's my output or my y value going to be? So using this graph to find f of 4 and g of 4, if I go to where x is 4 and then look at my points, on f of x, I have the point 4, 9. So f of 4 is equal to 9, because when I plug in 4, I get 9 out. Similarly, if I look at g of x, if I plug in 4, I get 2 out for my y value of that point, so g of 4 is equal to 2. Which means if I go back and actually do f of 4 plus g of 4, I'm going to have 9 plus 2, which is just going to equal 11 for my final result. Using the table for f minus g of negative 2, similarly, I'm going to look at them individually. So I'll look at f of negative 2 and g of negative 2 and then subtract them. So if I go over to my table and find where my input value is negative 2, tells me f of x and g of x. F of x is negative 3, g of x is undefined. So what I'm trying to do is negative 3 minus an undefined value. But if I have an undefined value, I can't really subtract that. So my total combined result is still going to be undefined. It's not really said what it's equal to. Domain of a function is all of your possible input values that you can plug in and still get real numbers out for your output.
So the key is you can't have anything that when you plug it in gives you any imaginary numbers, which if you think about it is anytime you have an even root with negative numbers inside of it, you can't include any x values that make that happen. And you also have to get an actual defined value out, so you can't include any values that make you divide by 0. So those are the main things to look for in your domain.
Let's look at a few functions here. So sometimes it's also handy to think about a graph. So if you're thinking about f of x equals 2x plus 3 and trying to determine, well, is there any way I would get a complex imaginary number out or divide by 0? No, there's not, because this is just a regular linear function. It continues in the negative direction and positive direction forever, left and right. Any real number that you plug in is going to give you a real value out. So your domain is just all real numbers from negative infinity to positive infinity. If you look at 5 over x minus 1, we can't have any x values that make us divide by 0. So since there's division here, we have to make sure that we exclude anything that makes our denominator x minus 1 equal to 0. If you set x minus 1 equal to 0 and think about what would make that happen, you can solve your equation and go, well, x equals 1 would make that denominator equal to 0, so we're going to have to exclude x equals 1 from my domain. Any other real number should work, but I have to skip over 1 itself, so negative infinity to 1 with the parentheses, and then 1 to positive infinity. Now we have a square root involved, so if I'm going to only get real numbers out, that means that my inside of my radical has to be greater than or equal to 0. So if you write yourself an inequality and just solve it, be like, oh, what makes 2x minus 1 greater than or equal to 0? Those are the x values that will work to give you real numbers out for your output. So add 1, divide by 2. X values greater than or equal to 1/2 are going to give you positives inside your radical, so real numbers out. One reminder, this was a square root. If it had been like a cube root or a fifth root and odd root, then we'd get real numbers out no matter what, and it'd just be negative infinity to infinity. We looked at domain of just single functions. Now we're going to look at domain of some different function operations. So nice thing on these is whether you add, subtract, or multiply functions together, it's not going to change the domain. Those three are all going to have the same domain. But when you throw in some division, like on D, then we're going to have to check for possible additional restrictions because we can't include anything that would make us divide by 0. So g of x, if g of x equals 0, we're going to have to throw that x value out. All right, so let's start with our domain of f and g individually, because if it's going to be part of a domain of a combination of those two functions, it has to be in the domain of both of them. So for f of x, we can't include x equals 0 because we have 1 divided by x, so 0 would make us divide by 0. Anything else will work. For g of x, we've got square root of 3x plus 1, so it's an even radical, which means we need the values inside of it to be greater than or equal to 0 to get real numbers. So let's write our little inequality here and solve it. Subtract 1, divide by 3. We need our x values to be greater than or equal to negative 1/3 to give us real numbers out for that one. And then to be part of my domain of f plus g of x, f minus g of x, f times g of x, that combines both of those, our x values have to meet both of these requirements. So we need any x value that is not 0 and also greater than or equal to negative 1/3. I kind of like to draw out a visual here because it makes it easier for me to think about. So let me do a little number line here. 1, negative 1. Actually, I have something happen at negative 1/3, so let's make that 1/3. Okay, so I'm gonna draw in red all the values that work for my function f of x. So everything except 0. So I did a little open circle at 0 because I'm skipping over 0 for my domain there. And then if I look at g of x, the only values that work in its domain are values greater than or equal to negative 1/3. Now, my values that meet both of these requirements are the places where those domains overlap at. So from negative 1/3 to 0, and then skip over because that doesn't work for f of x, and then starting back up from 0 to positive infinity. So my domain of a, b, and c is 1/3, negative 1/3 with a bracket to 0, and then union 0 to infinity. Now I said on D you have to watch out for any additional values that make you divide by 0. So I can't include any x values that make g of x equal to 0. So instead, I have to have 3x plus 1 be greater than 0, not equal to it, which essentially just means I'm going to have to exclude 1/3 itself and use a parentheses instead of a bracket.